Okay, so this is a quick demo of the visual system of the little AI bot that I'm building. So basically this bot plays Atari Space Invaders. This is an example of the bot playing over here. It's still training, so he's not really doing much yet. But this is just to give you an idea of the input. So what we want to do is, this is obviously a pretty big input. We're not really going to be able to handle that on an edge device. So what we want to do is first compress this input down to something much smaller that still reflects all of those, critical information that we need for the bot to make decisions about, what to do in this environment. And so, in order to do that, what we have is this encoder. So I built this encoder-decoder network, and I'll just run it now, fire it up. And so what this does is it pulls images of Space Invaders out and encodes and decodes them. And so first thing it does is let's just get all the windows sorted out here. There's the decoder windows. These are the three different latent spaces, and these are the inputs. Okay, so these are the two inputs that are going into the network. The first thing is they've been segmented out. The segmentation is just, and what I mean by segmented out is, you'll notice that the where the player is all green because that's in one channel, that's in one image, and then in the other image is all the shots that are going back and forth. That's in the red channel, and then in the blue channel you've got the actual invaders itself, and then that's three of the channels. There's another channel here which is the barriers. So if we look at Space Invaders, there's barriers, you hide behind them, right? So this channel is reflecting the status of the barriers. Yeah, so these are the different inputs. And then the final one is this is a coord conv input. So there's two channels, one for X and one for Y coordinates, shown in blue and green and blue here. So altogether this is six channels. Yeah, 6 channels of input. So the original image has been split into these 6 channels, and then over here we will see the breakdown of the different latent spaces. So before I do the latent spaces, actually, let me show you. Here we go. So this is what the decoder channel looks like. So what's happening here is the network compresses it down to a much smaller representation, and then it blows it back up again. And so this is the original that's going in, and on this side here we have the output. Right, so this is the output. I didn't actually train this to be very sharp. I was hoping that I might avoid some overfitting by doing that, but in any case, you can see that it's able to reconstruct the output from the once it's been compressed. Then in the middle, here you can see a few different things being compressed. So let's take a look at the shots first. The shots are the barriers are probably the most obvious, right? So if you look, this is the compressed representation of the barriers. So this image is 480 by, I think it's 200. It's 210 by 160, something like that. And I've compressed it down here to 20 by, I think it's about 20 by 11. This input. So this has been compressed by a factor of about 10. And this is what it looks like in the latent space. So you can see each barrier is represented by a pixel in this space, and then the intensity of the pixel ends up being like, how damaged the barrier is. That's kind of, I didn't encode it that way. That's just what the net figured out to do. And then we have these guys. This is the invaders. So you can see the block of invaders. Depending upon the shape, looks like it's sort of encoded in an outline or something. I don't know. The invaders are kind of a particular shade of grey. The invader block has been encoded that way. So again, that's the invaders compressed down in the latent space, And here's the player, and you can see here, so this is just the player's been encoded into this space here, and he flashes different colors depending upon his exact position, because he can be in a wide set of positions here, and he's compressed down there. So yeah, so these are the different ones. The shots, do I have the shots? Maybe I don't have the shots. It looks like I forgot on it. Here's the shots. There you go. This actually took the most work is to get the shots accurately reflected, because as you can see they cover the whole space and they're quite tiny, and the pattern is pretty random. So, but I did manage to get them encoded pretty well, I think, pretty accurately. So this latent space here reflects the shot position of all the different shots. Okay, so that is the first step of the visual system. The next step is to actually compress each of these further. So I'm pretty sure I can compress this down a lot, you know, because it doesn't really need all these pixels here, right? So we can get this even smaller. Definitely these can be made smaller too. I'm not sure the shots can be made any smaller. You know, I might try to leave them sort of as they are, and the invaders probably I'll leave them as they are too. Or we'll see. Maybe I think I can compress these maybe down to sort of 8 pixels or something like that. We'll have to try and see. But anyway, so this is where I'm up to in encoding the images.